Assalamu alaikum. In this video, I will be doing the hands-on related to our project in context of MRI, acoustic signals, and genetics. And later on, we will be moving towards, multimodality or the AI agentic systems. But before that, I want to discuss a very important point. We are using AI, and every time we let AI finish our thought, a part of our brain goes quiet and it might not come back on its own. I want to be very clear about something before I move further. I'm not an AI doomer. Okay, I'm using AI every single day in my research, in my teaching, in my writing, and so on. But there is a difference between using AI as an extension of your thinking and outsourcing your thinking to it entirely. So use of AI as an extension of your brain, not an as a replacement. Okay, you do not have to use it as a replacement. Why? I'm going to tell you the answer of this question. One is making you sharper. The other is quietly making you weaker. Everyone says AI is making us smarter. The data on how our brains are actually changing tells a very different story. Think of it the way you would think about a calculator. A calculator doesn't make you, worse at mathematics if you already understand the maths, but it just makes you faster. On the other hand, if you never have learned the math in the first place, the calculator isn't an extension of your ability, but it becomes a replacement. Same goes for Python, cloud computing, AI, or any skill that you want to learn using AI. And that exact distinction is what's happening right now with AI and how we think that why I wanted to open this video with it before we get into the research. As you all know that cognitive decline used to be an old age problem, but here in 2026, researchers are watching early signs show up decades sooner, and I will show you what is the reason. It is not to scare you, but to make you aware because awareness is the entire point of an extension mindset. We are having 5 factors that are reshaping our brains. Number one, reduced cognitive load. When AI handles recall, calculation, and even basic decision making for us, the brain simply exercises those circuits less, like any of the muscles in our body. Or a circuit you stop using, it starts to weaken. Number two, lifestyle and family structure. It is a shift of a lifestyle and a family structure. As you can recall in your own household, that a generation ago, decisions, financials, medicals, even day to day stuff ran through elders in the households. These activities was not only triggering ongoing dialogue, memory recall, and social cognitive engagement, but they were making us healthy inside the brain. But now, fast-paced lifestyles replaces that structure. A layer of daily mental exercises quietly disappears. And this is one of the reasons our elders, even our young generation, suffers with diseases like Alzheimer's. Number three, epigenetic factors. Our environmental factors like stress, sleep, pollution, even trauma can switch certain genes related to brain health on or off without changing the DNA itself. This is an active area of research in the neurodegeneration research space right now. Number four, diet. What we eat directly affects inflammation and vascular health in the brain. Taking processed food, which is often low in the nutrients, directly linked to the brain needs. It is significantly linked to a faster cognitive aging. And that's why we are having cognitive decline, cognitive, deduction. We cannot even think properly. We cannot have a proper focus. Number five, screen and mobile usage. Constant notification driven attention, switching, and trains the brain for short bursts of focus, not sustained and deep thinking. Because sustained and deep thinking, it's exactly the kind of activity that protects cognitive reserve over time. None of these factors on their own causes a disease, but stacked together over number of years, they raise the risk profile. For the exact condition I have spent last couple of years of our research, we are trying to catch Alzheimer's earlier. Over 55 million people are affected by this disease and they are living by it. But still, doctors cannot catch what is wrong about this disease. And I'm about to show you how exactly why. Those 5 habits we have already discussed are quietly reshaping your brain. And one disease takes that kind of damage and makes it irreversible. Yes, that is Alzheimer. Alzheimer's is a neurodegenerative disorder. And the defining problem with it isn't is like the lack of treatment option. It's that by the time most people are diagnosed, the window for the early intervention has already been closed. As I said, the disease affects over 55 million people worldwide, and the single biggest obstacle to helping them isn't it the medicine. It's how the late we are identifying it. As a researcher, we have spent almost 4 years on this problem, the problem of late diagnosis. And I can tell you that this diagnosis isn't the hard part, the timing is. So, those factors that we have already discussed, in addition to them, there is one more factor. Today, the most diagnostic pathways lean on a single modality, and that is just considering, for example, a brain scan, only a cognitive test, or just a genetic inference. One brain scan, one memory test, or just a genetic marker, each one misses this disease alone, and the gap is costing people years. Each one of those used in isolation misses the things that the other would catch. A scan can look clean while speech patterns are already shifting. A cognitive test can look borderline while imaging shows a clear structural change in the atrophied region of the brain. Using one at a time means the doctors are working with a fraction of the picture. And by the time all three finally lined up into a confirmed diagnosis, valuable time for the early intervention is often already closed. That single signal limitation is exactly the gap our research team is trying to close. So, if you were thinking the biggest problem with Alzheimer's is that there is no cure, it's not. It's that we find out years too late to use the options that we already have. So, for example, if one signal alone keep missing the disease, the fix isn't it a better signal test. It's combining the test no one had combined before. Most AI health tools chase one data source at a time and try to perfect it. We did the opposite and it performed better. We kept asking our students what happens if you fuse these three separate AI models into a signal diagnosis system. So when I say these three separate models, we are referring to MRI model, we are referring to an acoustic model that is trained on spontaneous speech, and the third one is the model that is trained on genomics. So when we tried to fuse these models together, the answer became the project we have spent almost 4 years. And that is the project of multi-modality solution for Alzheimer's detection. In fact, we built an AI that reads a brain scan, listens to your voice, and reads your genetic inference or the genetic markers. Then it analyzes with itself until it agrees on one signal answer. So, in short, consider it that you are having a radiologist, a speech pathologist, and a geneticist in one room analyzing over the same patient. And that's basically the software we have already built. We built an AI that reads a brain scan, listens to your voice, and reads your genetic markers. Then it analyzes with itself until it agrees on one answer. This is the core idea behind multimodality AI. And it's one of the fastest growing direction in applied machine learning right now. Not just healthcare, but across the field. Instead of training one large model to do everything, you train a specialized models on specialized data and let a separate model learn how to weight and combine their outputs. It mirrors how expert teams actually work. Nobody expects one doctor to be a radiologist, a speech pathologist, and a geneticist at once. You get a team, and the team's combined judgment beats any one specialist working alone. That's the same case of multimodality. We call it NeuroSense, a lightweight system for early Alzheimer's prediction that fuses three modalities instead of relying on one. So the first one is MRI brain scan, the second one is spontaneous speech model, and the third one is the genetic inference model. So each modality is analyzed by its own specialized model. For instance, a CNN handles the imaging, and the random forest models handle the speech and the genomic data. And finally, a meta learner then fuses all three predictions into a single, more confident diagnosis. Most benchmark systems built for early Alzheimer's prediction stop at one modality, and at best two. As for we have found, there wasn't a deployed, accessible, cloud based system which is doing this with all three at once. And unlike a lot of AI diagnostic tools, this isn't a black box. We built post hoc directly into the system. So it does not just output a number, it shows which brain regions, which speech patterns actually drove that prediction. Go check out our short demo built by our team, and then I will see you in the hands on.